Hi there, welcome to BrilliantMaths.com, where every student has an opportunity to excel in math. Subscribe to our website and you'll be glad you did. We have modules that cover secondary and primary school mathematics. Today's lesson is actually taken from Brilliant Maths Module 4. Let's go for a class. Today we want to look at angle properties, and we'll start with points, lines, and angles. A point is a specific or exact position and has no size. That means it does not have any length, it does not have any thickness or width. It is usually indicated by a dot, and it is named with an alphabet. So we have point A. A line is a set of points joined together. It can either be curved, we have a curved line here, or a broken line, or a straight line. So when you have several points that are joined together, that will give you a line. A line interval is a section of a line. That means from one point of the line to the other, like we have here. We have a line, and then from point A to point B is a line interval. Then we have a ray. A ray starts at a point and continues infinitely. So it continues to infinity. It has no end, but it has a starting point. So that's ray CD. It can also be written with an arrow on top. Three or more points that lie on a straight line are said to be collinear. So collinear points are points that lie on a straight line. So when 2, 3, or more points are on a straight line, then they are said to be collinear. Then we have intersecting lines. Lines that have a common point. Lines that meet at a particular point are said to be intersecting. Let's look at some more. Still looking at vocabulary involved in angle properties, lines, points, and angles. We have transversals, perpendicular lines, and parallel lines. What is a transversal? A line that passes through two lines in the same plane at two distinct points is called a transversal. So we have these two lines. So let's say line AB and line CD. The line here is a transversal, so let's call it line XY. So XY is a transversal. It's a very important property. Perpendicular lines. Perpendicular lines are lines that meet at right angles. If you have two lines that meet at right angles, then those two lines are said to be perpendicular. Very important too. Then we have parallel lines. Parallel lines are lines that have equal distance between them. The distance between the lines, the distance between them is the same, no matter how far you stretch the lines. So because the distance between them is always the same, then the lines can never meet. So parallel lines are lines that do not meet. They are always the same distance apart. So this is a set of parallel lines, and this is another set of parallel lines. It doesn't have to be horizontal or vertical before you identify that they are parallel. They can actually be running in any direction, but as long as the distance between the lines is constant, is the same, then the lines are parallel. Still looking at points, lines, and angles, we want to consider angles, what an angle is, and the different types of angles. An angle is formed when two lines intersect at a common point called a vertex. Like what we have here, we have two lines, line AB and line BC, and they meet at B. So B is the vertex, and that's where the angle is formed. The amount of turning is measured by the angle. So the turn from the line BA to BC constitutes the angle. So the angle is the measure of that turn. B is called the vertex of the angle. Line AB is called an arm of the angle. And then line BC or line CB is another arm. So an angle actually has two arms. Angles are usually labeled in this form with the letter at the middle. Angles are usually labeled in this form with the alphabet at the center, the alphabet where the angle is. So we'll call this angle ABC. We have a little mark on top of the B to indicate that the angle is at B, or angle ABC with B at the center, showing that the angle is actually formed at B. Or it could also be called angle CBA. That's a mark of angle. This indicates as an angle. Or simply angle B. So you need to be able to know how to label angles. So take note of that. Then types of angles. There are about 5 different types of angles. Here we have acute angles. Acute angles are less than 90 degrees. So let's say this is the mark. That's the line, and then the amount of turn is less than 90 degrees. So that's an acute angle. So acute angles are acute. They are less than 90 degrees. Obtuse angles are greater than 90 degrees, but they are less than 180. So this is an obtuse angle. It's greater than 90. An angle of 90 will ordinarily be perpendicular. The lines will be perpendicular. But it's greater than 90 degrees, but less than 180. Reflex angles are greater than 180 degrees, but less than 360. So let's see. We have an example of a reflex angle. So the bottom part there is reflex. It's greater than 180, but it's less than 360. Then the complete revolution is equal to 360 degrees. It goes round completely. Or it could also be the angle at a point. So next, let's look at right angles and straight angles. So next, we just want to consider a few more points, looking at points, lines, and angles. A right angle measures 90 degrees. That means that the lines that form the right angle are perpendicular. We talked about that earlier on. Perpendicular lines meet at 90 degrees. So when you have two lines that meet at 90 degrees, then the angle they form is an angle of 90 degrees. Straight angle. A straight angle measures 180 degrees. That's two right angles joined together. Then you have angles at a point, like what I have here. At this point, angles at a point add up to 360. So we have angle A plus B plus C, and the total will be 360 degrees. These are very important facts. And also, it's good for us to know that the sum of the angles in a triangle is equal to 180 degrees. So if you add up the angles you have in a triangle, the total should be 180 degrees. So we have A plus B plus C is equal to 180 degrees. And also, when you have a quadrilateral is a four-sided figure, like a square, a rectangle, a trapezium, a parallelogram. Those are all examples of quadrilaterals. The sum of the angles in a quadrilateral adds up to 360 degrees. This is a square, kind of. So angle P plus Q plus S plus R would give you 360 degrees. But if it's a square, that means that all the angles are equal because the sides are all equal in a square. Here we have a trapezium. Yes, because these two sides are parallel. So that's the trapezium. So the sum of the angles, P plus Q plus R plus S, would give you 360 degrees.
3, 2, 1, and action.
In this part of the lesson, we want to learn how to measure angles. So we have a few angles drawn. 1, 2, 3, 4, 5, 6. We have 6 angles to measure. And I will decide for each of them what part of the angle we're actually going to measure. We're going to measure the inner angle or the back side. So for the first one, let's measure the angle in between the lines. Measure angles. We're looking at measuring and drawing angles, but first we learn to measure the angles. How do we measure an angle? This is called an angle measurer or a protractor. It's used to measure angles. To measure an angle, find the center of the protractor. This is what we call the center of the protractor, and put it on the vertex, directly the point where the two arms of the angle meet, in such a way that the angle you're measuring is within the protractor. If you turn it this way, you will not be able to measure the angle because the angle is out of the measuring area. But if it's this way, then you can position it properly and then measure. So we'll put the center of the protractor right on the vertex, and then align the line of the protractor to the arm, to one arm of the angle, and then read the inner or outer measure. So watch me. That's the center, and I'm aligning it to this arm of the angle. So the center, the line of the protractor, and then I would read the outer measure, 10, 20, 30. I would read that instead of the inner measure that ends at 180 degrees. So this angle measures from 0, 10, 20, 30, all the way to 100. So the measure of this angle is 100 degrees. We can also measure it from the other side. Let's see how that works. Again, the center of the protractor on the vertex. So we'll place it. Center on the vertex. And then we read from 0. So that's we're reading the inner measure this time. So 10, 20, 30, 40, all the way to 100. So whichever one you use, you should get the same answer. So that angle measures 100 degrees. So what type of angle is it? Is it an acute angle or an obtuse angle or a reflex angle? It's 100 degrees. So it's greater than 90 degrees, but less than 180. So it's an obtuse angle. So that's the first angle. So the second one, we want to measure that amount of 10. Again, we need to place our protractor in such a way that the area we're measuring is within the protractor. The center, we put it at the vertex. And then we read from the 0 that matches, and that's the outer measure. So from 0, 10, 20, 30, 40, the angle is 55 degrees. 55 degrees. 55 degrees. So what type of angle is it? It's less than 90 degrees, so it's an acute angle. So that's the second one. For the third one, I want to measure the back angle. And how do I do that? That angle is greater than 180 degrees. So we'll measure the inner angle and then subtract from 360 because that angle is reflex. All right, so that's the third angle. Again, center of protractor right on the vertex, and then it matches, align the zero line with the arm of the angle. So that is an angle of 32 degrees. 32 degrees. So if this angle is 32 degrees, the reflex angle will be 360 degrees minus 32 degrees. And what would that be? 10 take away 2 is 8. 5 take away 3 is 2. So the angle is 328 degrees. That's the reflex angle. So for the last angle, angle 4, let's decide what to measure. If we measure this part, we're measuring a reflex angle. If we measure the inner part, it's obviously an obtuse angle. That means that when you have a reflex angle, the inner angle will either be acute or obtuse. That's also very important. So this time, I want to align the arm of the angle from this side. So that's the center of my protractor. So I align it at the center, as you can see. Then I turn this so that it matches the zero line. Good. Then I can measure. So 0, 10, 20. I'm reading the outer measure of the protractor. 10, 20, 30, 40, all the way to 100 and, I want to be careful, all the way to 164 degrees. So that angle is 164 degrees. And we all know that it's greater than 90 but less than 180, so it's an obtuse angle. So measuring angles is an activity you need to practice to be able to master it. And accuracy is very, very important. So next, let's look at how to draw angles. Next, we want to actually draw specific angles. We want to draw an angle of 23 degrees. That's an acute angle. An angle of 125 degrees, which is obtuse. An angle of 300 degrees, which is the reflex angle. And an angle of 345 degrees, which is also a reflex angle. And they are all very easy. So the first step is you're using your protractor or your angle measurer. So put down your protractor. Mark the center. All right? So that's the center of the protractor. I want my angle to come from here. So I draw it that way. And that's my vertex. Since I want to draw an angle of 23 degrees, I read from 0 to 23. So that's 10, 20, 21, 22, 23. So I put a dot there or a mark, just to mark the point. Then I take my angle measurer. I join the vertex to the point. Accuracy is very important. I draw a straight line. Then you take off your protractor and then measure to check. Center, center, 10, 20, 23. Easy. Then you label your angle, 23 degrees. If I wanted the angle to face the other side, you repeat the same process, but you work from that side of the angle. So let's see the next one. 125 degrees. So that's my angle measurer. So this time, that's the center. Then I draw my straight line. Okay? 125. 0. Be careful. I'm just making sure that it aligns. Good. So 0, 10, 20, 30, 40, 90, 100, 120, 125. It's right here. This is my vertex, because that's where I put the center of my protractor. So I'm just going to join the vertex to the mark of 125. So that is an angle of 125 degrees. You can obviously see that it's bigger than a right angle. So you measure again to check. This time I'll read from this 0, put my center there, and it is right on from 0. Make sure it aligns all the way to 125. You can see that. And you label your angle, 125 degrees. And that's an obtuse angle like we all know. Drawing an angle of 300 degrees, which is a reflex angle, the first step is to subtract that from 360, because the angle measurer can only measure up to 180 degrees. 360 degrees minus 300 degrees is equal to 60 degrees. So I'm going to draw an angle of 60 degrees and then measure the back. So 60 degrees. Let's do that from here. This is the center of my protractor, so that's going to be my vertex. So 0, 10, 20, 30, 50, 60. I join the point to the vertex. And that's my angle of 60 degrees. So if that is 60, then this is 300 degrees. Interesting, right? And easy too. So 345 degrees, the same thing. We'll subtract 345 from 360. And what do we have? That will be 15 degrees. So we're going to draw an angle of 15 degrees. I'll do that here. Center of my protractor. Then, remember that's going to be my vertex. Then 15 degrees, 0, 10, 15. That's a very small angle. And then I join. So if this is 15 degrees, then this is my angle that measures 345 degrees. So that's easy to work with. Obtuse angles. Let's look at a few angle facts. Complementary angles, supplementary angles. When are two angles said to be complementary? When both angles add up to 90 degrees. So we have two angles here, angle A and B. And the sum of A and B will be 90. So angle A and B are complementary angles. So we can say that A plus B, angle A plus angle B is equal to 90 degrees. So assuming we know that angle A is 50 degrees, so assuming A is 50 degrees, what is the value of B? So to find B, we know that angle B will be equal to 90 minus 50 degrees. So angle B is equal to 40 degrees. Take note of that. Supplementary angles add up to 180 degrees. So two angles are said to be supplementary if the two angles add up to 180. So here we have that x plus y is equal to 180 degrees. X and y are supplementary. Find x if y is 115 degrees. So you know that x plus y will give you 180, and y is equal to 115 degrees. So x will be equal to 180 degrees minus 115 degrees, and that will be 65 degrees. So angle 65 degrees and angle 115 degrees are supplementary angles. We have an example here. Find the value of x and the size of the unknown angles. We have three angles here. And as we can see, the three angles form a complete revolution. So the total of the three angles is equal to 360 degrees. So we have to find the value of x and the size of the unknown angles. That's 2x and 3x. We're just going to solve this simple equation. 3x plus 2x is 5x. So 5x is equal to 360 minus 30, and that is 330 degrees. So x is equal to 330 degrees. 330 degrees divided by 5. 5 into 33 is 6. Remember, 3 into 30 is 6. So x is equal to 66 degrees. So the size of the unknown angles, 2x will be 66 times 2, which is 6 times 2 is 12, carry 1, 12 plus 1, 130. And then 3x will be 66 times 3. 3 times 6 is 18. Carry 1. 3 times 6, 18, plus 1, 19. So that will be 198 degrees. And if you add all three angles, 198 plus 30 degrees plus 132 degrees. Let's see what we will get. 30 plus 132 is 162. And if you add 162 degrees to 198 degrees, what do we get? 10, carry 1, plus 9, 10, plus 6, 16, carry 1. We get 360 degrees. So the value of x is 66 degrees. And we've been able to find 2x, which is 132 degrees, and 3x, which is 198 degrees. Well done. How many minutes? Still looking at angle facts. Two angles are said to be adjacent when they have a common vertex and the line next to each other. So we have angle BAQ and angle CAQ. They are adjacent angles because they have a common vertex A, and they also have a common arm. The common arm is AQ. But you must note that adjacent angles do not overlap. So we cannot say that angle BAQ is adjacent to angle BAC, because angle BAQ and angle BAC overlaps. But BAQ is adjacent to CAQ. So please take note of that. Then vertically opposite angles. This is very interesting. You need this fact for the rest of mathematics in secondary school. Vertically opposite angles are equal. Vertically opposite angles are formed when two straight lines intersect. So let's say we have line AB, which intersects with line CD. So angle Y is vertically opposite to the angle that measures 70 degrees. Vertically opposite angles are equal. That's an angle fact. So Y is equal to 70 degrees. How do we find Z? This is a straight line. So 70 plus angle Z is equal to 180 degrees. So Z is equal to 180 minus 70. That's 110 degrees. And since we've agreed that vertically opposite angles are equal, the angle Z is equal to the angle X because they are vertically opposite. So X is also equal to 110 degrees. In the second diagram, we have angle 30 degrees there, and then angle Y. Y plus 30 will be equal to 180. So angle Y is equal to 180 degrees minus 30 degrees, which is equal to 150 degrees. And Y and Z are vertically opposite. So they are equal. So angle Z is equal to 150 degrees. This is very interesting. You can get some more practice from Brilliant Maths Module 4. Next, we want to look at angles in parallel lines. Let's look at figure 1 and figure 2 on the board and take note of the difference between both of them. In figure 1, we have line PQ and line RS and a transversal MN. All right? The PQ is parallel to RS. And that has implications for the angles that are formed by the transversal and the parallel lines. In figure 2, we have line WX and YZ. But in this case, WX and YZ are not parallel. We also have a transversal. So the fact that WX and YZ are not parallel also have implications regarding the angles that are formed. So take note of that. So back to figure 1. A, B, C, D are angles at a point. So the sum of the 4 angles will give you 360. Let's try to remember some of the rules and the properties we know already. B and D are vertically opposite, so they are equal. The same applies to A and C. Let's now look at corresponding angles. When do you say 2 angles are corresponding? 2 angles are corresponding when they are on the same side of the transversal in the same position on the 2 lines. So angle B and angle F are corresponding. They are on top of the angle, they are on top of the line, and they are on the same side of the transversal. So corresponding angles form an F shape, kind of. You can see the F shape. So B and F are corresponding. C and G are also corresponding. They're on the same side, same position. They're on the same side, same position under the parallel lines. There are more corresponding angles. A and E are corresponding, and D and H are corresponding. So the sets of corresponding angles are BF, B and F, C and G, A and E, and finally D and H. So those are the pairs of corresponding angles. Let's look out for the alternate angles. The alternate angles form a Z shape, a Z shape. So C and E are alternate. And also D and F are alternate. So we have C and E, angle C and angle E. They are alternate. And here we now have C and E, and here we have D and F. Then we have co-interior angles. Co-interior angles are in the middle. C and F are co-interior angles. And co-interior angles add up to 180 degrees. So they are supplementary. So the co-interior angles we have here are C and F and D and E. They form a C-shaped kind of. That's the formation of co-interior angles. So C and F and angle D and angle E. Those are examples of co-interior angles in figure 1. The major difference between the angles formed by transversals and parallel lines and the angles formed by transversals and lines that are not parallel is that when the lines are parallel, the corresponding angles are equal. So in figure 1, all the corresponding angles are equal. So we can say that B and F are equal because they are corresponding and they are formed by parallel lines. In figure 2, B and F are also corresponding, but they are not equal. It's important for you to take note of that. They are not equal because the lines that form them are not parallel. That's a major reason. You can see from the drawing that they are not. In the same way, A and E are corresponding, but they are not equal because WX and line YZ are not parallel. Let's look at an example. Find the value of the marked angles. We have two parallel lines, and they are intersected by a transversal. Because they are parallel, the corresponding lines, because they are parallel, the corresponding angles in that figure will be equal. The alternate angles will be equal. So let's look at how we can find all the marked angles. We only have 83 here, but we can work with that. 83 and A are co-interior angles. So they add up to 180 degrees. So we can actually find the value of A. So angle A is equal to 180 degrees minus 83 degrees. 10 take away 3 is 7. And we have 7 left here. 17 take away 8 is 9. So angle A is 97 degrees. What about angle B? Angle A and B are on a straight line. So B is equal to 180 minus A. That means that B is 83 degrees. And we know that B and 83 degrees are alternate. And because the lines that have formed them are parallel, they are equal. So B is equal to 83 degrees. Angle C. Again, C and 83 are on a straight line, 180. So C is equal to 97 degrees. We can also use the fact that C and A are corresponding angles formed by parallel lines, so they are equal. Angle D. D is vertically opposite to 83, and vertically opposite angles are equal. So D is 83 degrees. Next is E. So you can use any of the facts that you know already, that E and C are vertically opposite, or E and 83 will add up to give you 180. So E is equal to C. And since we know C already, E is equal to 97 degrees. We found A, B, C, D, E, so we are left with F and G. So we'll put F here. F is vertically opposite to B, so they are equal. And B is equal to 83 degrees. G is vertically opposite to A, so they are also equal. And A is equal to 97 degrees. If you look at the corresponding angles, you see that they are equal. Let's look out for the corresponding angles. C and A are corresponding. A is 97, C is 97. Remember that the lines are parallel lines, so the corresponding angles are equal. Another set of corresponding angles, 83 degrees and F. Is F equal to 83? Yes, it is. So that's correct. Corresponding angles, D and B. B and D, 83 degrees. So we are on track. Let's look at the alternate angles. Alternate. It forms a Z shape. 83 and B. And alternate angles formed by parallel lines are equal. And B is also 83 degrees. So all you need to do is familiarize yourself with how to identify angles that are corresponding, angles that are alternate, angles that are co-interior, and you'll be able to solve any problem that is related to them. You can get more practice from Brilliant Maths Module 4. I hope you enjoyed that lesson. I loved it. Get more exercises and practice from brilliantmaths.com. Get a copy of Brilliant Maths Module 4. Subscribe for any of the modules that you would like to work with, and you'll be glad you did. My name is Ngozi Orevaoge. And always remember that maths is fun.